Hello, everybody, and welcome to today's Green Building Advisor Expert Exchange, which is focused on choosing products and materials. And today, our panel of health, construction, and design professionals will share their insights to help you balance the wide range of things you need to think about that affect these choices, including, among other things, performance, sustainability, durability, occupant health, cost, and style. My name is Rob Watzak, and I'll be the host and moderator this evening. So first off, I want to thank Rockwool for sponsoring today's webinar. You probably all know that Rockwool makes a wide range of mineral wool insulation products, including their popular Comfort Bat and Comfort Board lines. And you can go to rockwool.com to learn more about all of their products. We have a great group of people with a lot to talk about, so I'll keep my introductions brief. First off, we have Dr. Stephanie Taylor, who's the founder and CEO of Building for Health, a consulting service for evaluating the health impact of the built environment in real time. Thanks for joining us, Stephanie.
Thank you for inviting me.
Next, we have Lucas Johnson, who is known as the chief building nerd at Valley Homes, and he's been involved in all aspects of high performance construction, from basic material acquisition all the way up to the building science of the projects that they work on. Welcome, Lucas. Okay, and we also have Fernando Pajes Ruiz. He is a longtime contributor and a friend here at GBA and Fine Home Building Magazine, with many years under his belt, both building great homes and reporting on the latest developments in residential and construction and design for us. And it's great to see you, Fernando.
Well, thank you, Robert. I guess my face tells it all in terms of how many years I have under my.
Also, we have Lindsay Shack, who's an architect and co-founder of Love Shack Architecture. And her work regularly involves advances in construction technology, including advancing building codes to adopt new materials and techniques in her home state of Montana. Is that correct, Lindsay?
Yes, we practice in Montana, Idaho, and Wyoming.
Okay, well, thank you very much for being here.
Thanks for having me.
And we also have Lacey Hoskins, who runs Novo Sustainability, which merges sustainable design and construction principles with employee health and wellness initiatives. Thanks so much for being here, Lacey.
Thank you.
So now, the reason I believe this is so popular, this topic is so popular, is pretty obvious, is that we're asking our buildings to do more and more than ever. And while advances in technology have made our choices so much more complicated, and the big question of the day is, how can we efficiently and effectively make the right choices for all of the things I was talking about earlier, whether it be health and cost and sustainability and durability, and of course style, because people want a house to look good in order for them to be willing to take care of it and live in it. And so I guess I'll just pose this question to all of you, and anyone can jump in and talk at it. Well, what are some of the benchmarks you should be thinking about for choosing materials for a construction project? Lucas, I think you said you're really involved in specifying materials in a lot of large scale projects. Is that correct? I mean, how do you go about that?
Large scale, not so much. We focus mostly on single family and small multifamily, but we do a high degree, high volume of consulting work, and so we do get involved in a lot of projects. We have developed this thing we call the 5 factors of good building, which is an attempt to force a more holistic view when doing product specification, so that we're not blinded by having overly simplified metrics, like just looking at R value for insulation, for instance. We want to look at a lot of other criteria, like embodied carbon, for instance, or life cycle carbon impact, health, durability, how it influences moisture dynamics in a building. There's quite a few different things we want to look at when we're making these kind of decisions. So the 2 articles I've contributed as part of this series are kind of about that whole process and how we do those things. And one of the most important things is figuring out where you're building. And I'm going to use that to tie into this chat window, which is very inspiring to see. There are people
Mhm.
from all over North America joining, which is really cool to see that, you know, the network is this big. It's very exciting. It's very,
Yeah.
so just wanted to mention that.
You said you had 5 criteria. Could you name them?
Sure, yeah. Comfort and health is one of the criteria. Durability and resiliency is another. Efficiency and renewables is another. And that tends to be in green building. Historically, we focus on efficiency or renewables and argue about those two things and forget about all the rest of this stuff, right? So that's just one of the 5 factors. Another one
Yes.
is my wife is an anthropologist. She's a professor of anthropology and has really inspired me through her work to pay a lot more attention to social justice issues. So social justice is one of the criteria. It's, in my opinion, quite unfair that we ask workers to expose themselves to highly carcinogenic insulation materials and other things like
Absolutely.
that. It's a major problem. And then life cycle carbon impact is the 5th of those factors.
Now, that list of factors, is that something that you've kind of has evolved over a period of time? And how, do you feel like any one is more important, or do you sort of start with from a certain end of that list?
Yeah, great question. So two things. One is, looking back in time, I think all of us will admit we've made a number of mistakes, and there's been a lot of learning throughout our career, right? I think that's a really important thing to share, because a lot of times when you're stressing best practices, you're telling a lot of people that what they're doing now is wrong without maybe acknowledging that what we've done in the past has also been wrong, right? So for a long time, I was very much an efficiency first guy, right? Like, that's what I paid attention to. That's what I did. If buildings were efficient, everything was fine. They were going to be comfortable, healthy, durable. We're going to solve the climate crisis. And then you start digging deeper and deeper and deeper, and the data does not support that claim. The data supports the saying that I've come to, which is the ingredients create the results. Right? What the building is made out of is what the building is. And that's true in terms of carbon impact. That's true in terms of comfort and health, durability, resiliency, all the 5 factors, right? So yeah, I've definitely changed over time quite a bit, the focus. And it's been about 2 decades now. I've been honored to work on thousands and thousands of buildings in my career, from utility program management through designing them, being a retrofit contractor. Now building science and development is the work I focus on. And drawing from that data set, it really seemed like those 5 criteria become a good baseline metric for success. Of course, you also need to have like cost, availability, construction skills. All these other things are obviously important, but those are important across any project. So these 5 factors are primarily for ensuring we specify the right materials. I'll end with saying one of the big pro tips we've come to also is, it's important to determine what materials to use, but it might be even more important upfront to determine what materials not to use. So now we're kicking off a lot of our projects by putting together a do not use list. And anytime someone brings them up in a meeting, you're just like, yep, do not use list, moving on. But we could use spray foam to, no, we're not going to do that. That's lazy. We're going to come up with a better solution, right? Do not use list. So, and that's been the biggest shift in recent times, is going from trying to stress all the stuff you should do, which is kind of overwhelming, and really focus more on, this is the stuff you shouldn't use, because that list is a lot shorter.
Now, Lindsay, I know I saw in the notes that some of the things that you've dealt with are sort of promoting the use of new materials or new systems that actually, because Lucas was talking about the regional requirements. I know you say you work a lot in remote locations, and that affects some of the choices you make as well. Is that correct?
Yeah, working in rural Western, Eastern Montana, hard to reach places in mountainous regions, and then working in severe climate zones like 6 and 7 means that we have to really deal with severe conditions. And then also, maybe a smaller labor force, a labor force that has fewer resources and depth. And then there's a sourcing of the material. So everything that Lucas just shared is absolutely something that we are trying to bring to all of our projects as well. And then, it's just that we end up being, we definitely went through a process of sort of trying to advocate and really sort of say, here's all this information, you should really pay attention, to finally get to a point saying, this is what we do. And if you're going to work with our organization, this is the kinds of things that we are going to recommend. And, ultimately, it's up to our relationship with our contractor, relationship with our client, but that we're at least providing the platform for them to make choices that they've said fit their goals. And so I think one of our biggest qualifiers would be defining those goals in the beginning, right? So we say, this is what our goal for this project is. It's a carbon neutral project. It's a natural materials project. It's a passive house project. And passive house is really just about the energy. It's like, it doesn't get in as far into the materiality. So we have to go farther than that. And finding out where a client lands on that level of sort of desire for their project has everything to do with, our approach to it. But we've been getting good upfront of saying, if none of these things matter to this client that is interested in working with us, we're not really a good fit. There's a lot of people out there that want to work with architects that understand and can give them these options. And so we just want to focus on those projects. And so that's one of our qualifiers from the beginning. And like Lucas said, then we set those parameters early, and then we sort of give them all the choices they need to sort of fill that. And luckily, there's options we're finding that feel like they are as good or better and as, similarly cost and sourced as more conventional products. And I think maybe one of the challenges is being innovative in a new place where people are comfortable with the way they've been doing it for a long time. It's finding the language too, as the design professional, to say, hey, there's a new way that we might want to learn about, and I'm learning about it too. And it's not to communicate that somehow, how we did it before is something that we're being judgmental about. We have new information, and now we'd like to try this new system because we think it's great, and be brave enough to come with us. And as a new company and younger designers in the beginning, that was actually a pretty big challenge. It's a big risk for your client to be perceived in any sort of guinea pig for your project, right? So I think that, it's great to get to the point now where we have some projects to point back on and lean on to say, this is a successful choice for the client in the project.
Makes sense. Yeah, actually, one thing I'm really excited about is because I've been with GBA since the beginning. So this is back 2009 when, even the people who were deep into sustainable building or energy efficient building, we're just trying things out for the first time, and there wasn't really a lot of good data for people to go on. So there weren't this well-established resources for people to figure out what were the biggest priorities or what worked best. And this kind of reminds me of something that's but now we've got builders and architects who are well established, and we've got enough people out there who appreciate what they're trying to do, that they can say, well, no, this is the way we build. And so it's not like you're trying to convince someone to add these materials or these assemblies to a project. It's like, no, this is a priority for us. And like you said, if you want to find the kind of clients who appreciate that from the start. But one thing that you mentioned was you have new information, and that kind of reminds me of what we were talking about with Stephanie earlier about how we can't live in a bubble. We need data to make these decisions. And Stephanie, can you talk about how sort of you integrate what you know as a medical professional with working with the engineers and the material people to benefit this sort of process?
Sure. And I always feel a little anxious when I'm around these really like all you knowledgeable folks. I feel like, wait a minute, I'm a doctor. This is like, mostly I'm a doctor. But then I was looking at how in the hospital, people get infections from that exposure. And I began to realize that based on the organisms and the physical location, that I thought the building had something to do with that, but I didn't know anything about buildings. So I went back to school in my 40s and got my license in architecture, or got my master's in architecture, and then designed hospitals. And now I work a lot with ASHRAE engineers. But one of the real aha moments for me as a physician was looking at the hospital environment. So specifically patient rooms. And, I was working with infection control professionals. We were swabbing things and putting Petri dishes down and stuff like that. And I said, wait a minute, we have the most sensitive and specific Petri dish right here in the room, and we're collecting a ton of data already. And that's the patient. So I thought, wait a minute, why don't we use patient data, patient outcome data? And, I don't know if any of you have ever been in the hospital, but, they collect a lot of data on you, blood, urine, vital signs, et cetera. So I did a big study in the Chicago area where we analyzed patient rooms over 13 months. And we were looking at both the environmental parameters and also the microbiome of the building. And I'll talk about that in a sec. And we were correlating a massive amount of environmental data from inside the building with patient outcomes. And so to my surprise, in that study, the most powerful indoor metric that drove higher infection rates was low indoor relative humidity. And I was just like, this makes zero sense to me. So that we identified this range, 40 to 60% relative humidity, that was very beneficial to patient healing. And so I began to look at that, at the association between, both from an epidemiology and perspective, and as well as toxicology and microbiology, saying, what in the world does this water vapor level have to do with human health? And it ends up, it has to do a lot with human health, such as hydrating your respiratory epithelium so that your immune system functions properly, letting your skin, your epidermis and dermis be hydrated so that your immune system is able to actually protect you. So that's, for me, I come at this from what does the health data tell us about how we should be managing buildings? And so if you follow that moisture, that relative humidity, train of thought, what I have found is that choosing materials, perhaps not in high touch surfaces, and perhaps if you're in a hospital, not in a bone marrow transplant unit, but in your home or in your office, surfaces that have micro channels so that water vapor can adsorb to those micro channels. So after you take a shower, for example, the steam can go into these micro channels and modulate the indoor water vapor levels in a way that you don't get as much like condensation from thermal bridging. And so choosing materials that are porous to some degree. And then, oh my gosh. So then I started this company, Building for Health, where we monitor 11 indoor variables continuously. And we look at both those things like different particles, VOCs, ozone, humidity, temperature, NO2, SO2, carbon dioxide. Well, what we found is really like kind of mind-blowing in terms back to the humidity component. We found that the other indoor components that are harmful, such as ozone, which is highly inflammatory to your cells, it's less harmful when you have a moderate amount of water vapor in the air because you don't have the same cellular response. So what we're finding now is that keeping your relative humidity in this zone is not only good in itself, but it protects you from other indoor constituents or pollutants. So for example, it's just like so interesting when you look at the interactive chemistry of indoor air and how that relates to water vapor. And then the very last thing I'll say is, and this is a little harder to talk about in a pandemic era, but that is that, 95% of the microbes around us, bacteria, viruses, are good for us. We need microbes to live with us. And so, but you want the good ones, not the bad ones, obviously. So we're also finding that mid-range humidity actually preferentially chooses, or sort of through natural selection, allows the good bugs, the commensal ones, to survive. And you're not constantly selecting for the anhydrous, the moisture-resistant pathogenic organisms. So it's just like, it's so fascinating and important.
That
So-
was amazing.
Yeah.
Fantastic.
That confirms so many things that I've from your perspective that I've known as a building scientist, but to hear it from the medical perspective, it just further emphasizes what we were talking about before we started, more connection between the medical community and the building science community. It's And I'm also calling in from Tucson, Arizona, where it's always dry, and we have tons of issues with that, right?
Mhm.
Yeah.
So I actually grew up in Tucson.
No way.
My dad had a citrus grove. And so, talking about yin and yang, citrus and the desert, but we lived in this adobe house, and we had an evaporative cooling system that also happened to humidify, although that wasn't this identified, goal. But yeah, Tucson, I was just there recently speaking to Ashray.
But you had the environment you just spoke of, because you had porous walls that hold humidity. You had a very natural cooling system, which is basically water vapor, right? That's the most natural cooling system for a human being, I think for a mammal in general. So you were lived in the environment you spoke of. I was thinking of that when you were speaking, that why is it that like a mud house feels so fresh, so nice, so human, like such good human habitat, and I think you intuit a lot of what you were saying are things that we know intuitively when we experience it, and we say, yeah, this is very healthy for me. And then the building scientists often are focused on single issues, like Lucas was talking about Lucas's confession of being a energy efficiency nut, at one point, and we all have been, of course, because we thought that was the one thing. Is to be very careful about the arrogance that you can develop with a little bit of knowledge, and as things progress, it becomes so much more complex and so much more goes into it. Like, I wonder now, why don't I have a humidity, a humidistat in my house to know what the humidity is in my house? I'm sure that thanks to your work, we will.
I hope so.
We'll be installing them.
Could I just say one more quick thing about energy? So we found in a hospital study where in the operating room, air change rates are, Ashray and Ashy says they should be very, very, very high. So we did a study in a operating room in Indiana, or in a whole operating suite, and we found that if you maintain the humidity, we use 35% as our lower cutoff, you can actually turn down the air change rates by about 20% and have fewer airborne particles. So the hospital saved money from energy, and they also decreased their surgical site infections by a dramatic amount. So you can't really even put a price tag on a human life. But it's remarkable that it's not always, with proper humidification, you can turn down some of these other mechanical systems if you have them and have a safer indoor environment.
Well, this kind of leads me into, because we have these standards that are supposed to be here for our health and to help us make good choices, and the information's changing and evolving, and we're getting more and more in tune with it as time goes on. But I guess the big question is that to help our audience is, how do we get the right information to make the right choices for materials? Now, I know, Lacey, you haven't spoken yet, and I don't know if this is dropping a bomb on you, but how does this intersect with the work that you do?
Yeah, so I review product specifications for projects every single day. I'm not an architect, I'm a consultant. I work a lot on the commercial side, but I also am currently building my own house, a high performance house with a heavy focus on embodied carbon and healthy materials, and pulling from that experience of reviewing materials. And I think for me, certifications are a great benchmark. They're a starting point. They are not the be all end all by any means. But for someone who wants a quick list of kind of do this, don't do that, or like what Lucas was saying, don't do this, or, having using some of these tools, the one that I use regularly is a site called Ecomedes, and there's thousands of products, and you can search by different criteria, whether it's some sort of health product declaration, if that's what you're looking for, or an environmental product declaration, or any other sort of environmental certification. And to me, that's a perfect sort of intro into, okay, I know I want to do better and really focus on things. And that's an easy way to search for materials that have those sort of attributes.
Can I just pause for just 1 second? So how do you spell that? Just because we have some people in the
Sure.
audience saying, "What is that? What is it?"
Yeah.
Not just the audience. I'm waiting to write this down.
Yeah. So it's Ecomedes, ECOMEDES.
Okay.
And it's a great site. It has all kinds of products from interior finishes to structure components, insulation to all kinds of different building components, both for residential and commercial.
Okay. Now I know you mentioned you're building your own house, and I think I read some little story about how you have, we can have the best intentions, but in the real world, sometimes we have to make some compromises, right?
Yeah. So with our house, our focus, what we decided at the very start of the project that was really important to us, was trying to source as many materials as local as possible, for a lot of different reasons. But one was to support our local economy and also to reduce the embodied carbon footprint with our building materials. And I spent probably 6 months trying to find a local cabinet maker, someone who was in Maine or in the Maine vicinity, who I could work with to build the cabinets that we needed for our kitchen, and also, be involved in the finishes and the things like that they were using. And so I finally found one, and was really excited about it. And they had some staffing issues over the summer, right? Like 2 weeks before we were placing our order. And so we had to very quickly pivot and look for a different manufacturer. And we ended up going with, the sort of one of the bigger standard manufacturers of kitchen cabinets. But the thing that I looked for as a minimum from a cabinet standpoint is there's a sustainability seal through the Kitchen Cabinet Manufacturers Association, the KCMA, for these manufacturers to have some sort of they have to answer some environmental questions about their process and where they're sourcing their wood and things like that. And so I at least looked for that, because that was, in my mind, the minimum. At least they're doing something. It may not be as much as I would want, but at least they're doing something. And so that's how we ultimately ended up choosing our kitchen cabinet manufacturer from one of the major brands.
Oh, procurement logistics.
Yeah.
It's actually very tough. It's especially today with labor shortages and such, to find local things is difficult. And many of the local businesses have been driven out because they cannot compete. Cabinet shop, very difficult to compete with the home improvement stores and the online sales and such like that. So you're sort of stuck with a lot of things that we used to be able to source locally. It's I built a little house in Ecuador on the beach where everything was not only sourced locally, but actually from the property. It was harvested on the property of Ernie Bryant. And the interesting thing about it was we had none of the problems like adaptations to humidity. Like you have to get woods acclimatized to your house and such, and then the trims will split if they're not. We were able to use things that were practically green. And I'm here now. I just happened to be in Ecuador this week, and I was today at the house. Nothing has split, nothing has changed years later. And it's not been because we adapted it to the climate. It was adapted to the climate when we installed it. And the people that installed it were from the climate and all. There was a kind of a complete homogeneity in the whole process. It was my only time in life I was able to do that. It's not something I would do commonly in my business in the United States. It's be impossible. Sourcing natural materials in Houston is difficult, but it was quite an experience, and it was it gave me the sense, like I always considered lumber as wood, just something I bought at the lumberyard as pieces and parts of construction. And it was quite different to suddenly begin seeing the trees from which the lumber was extracted and having them milled and cut, and going with a local fellow who had me smell and taste the sap of the tree to recognize it and all. And you know how the cooks do this? You go to a fancy restaurant, they tell you, oh yes, the chef has grew these vegetables in his backyard, and you know, he smells the carrots every morning, you know, and there's that sense of continuity between the origin of the thing and your consumption of it. And it was that experience for me, which was really kind of a spiritual experience. So my association with that building is quite different than I have with any other building I have ever built or lived in throughout, as Robert said, my long life. By the way, next time, don't emphasize that so much.
Okay.
But you know, it's I think all of our consumption nowadays, all of it, clothing, food, everything, is much more conscious of the impact, that it's not just our experience of it or the cost that it has for us personally, or the enjoyment that it gives us, but you know, where it comes from. Certainly in food and clothing, all of these things are very important. You know, you don't see ladies wearing fur coats anymore. You know, there's a lot of change in our society where we're very aware of the fact that, you know, the cruelty, the abuse of other human beings, the impact on the environment are those things that we're concerned about, you know, to one degree or another. Unfortunately, as we've made amply clear so far in this discussion, it's a very difficult topic and involves so much detail that it requires a certain, even with a certain expertise, it's quite challenging because of all the you know, the counterbalancing things that occur, and then the unexpected things. Like I never thought about the relative indoor humidity.
Yeah.
I never thought about that. It's really obvious, and it's obvious in my experience, but I always thought it was because I'm Latin American and so I enjoy humid climates more than dry ones. But that just told me that there's so much more to go. So I have a very simple approach. It's only 3 steps, not 5. And and a lot of my clientele are actually interested, but it's very difficult to get so deep into the weeds with folks. So I think if they really are that deep in the weeds, then I would, you know, refer them to Lindsay and say, here, this is the person that you should work with. When you're done with your plans, bring them to me and I'll tell you what it might cost. But when the people that I deal with are really very average kinds of consumers, and I just have 3 criteria, one of which is health is my primary criteria. We live in a womb. Our houses are like a womb and we spend a lot of time in them. So the indoor health aspect of the house is important. And I do talk about that in a very simple way, you know, chemicals in the materials that you're using and choices and such, so that you don't have a toxic environment that you're sticking yourself and your kids, especially with a new house, which is what I do, because that's when all those you know, those volatile organic components and all are strongest, is when they're brand new, like the new car smell, right? The new house smell, not a good smell. So you know, I talk about those things and ventilation. I also talk about adequacy of purpose a lot. As I just I'm thinking of this because I had a client just yesterday discover that there are paints made out of whey, you know, like milk-based paint, whey paints that were used. They used to be the barn paints. You know, the barns were red because they mixed whey with some kind of metal oxide. And the way they had lots of whey because it was a waste product from the dairies. So they mixed it with this metal oxide and they painted the barns with the whey. Whitewashing, like Tom Sawyer, you know, Tom Sawyer, the book starts with whitewashing. That's whey that they're using. So there's been kind of a revival of that. And the barns were red because the iron component that they mixed with the whey would rust and turn red. Later on, they went to white because the dairy industry thought that white was purer and better association with milk than red. So red barns, now they're painted white. But a client of mine discovered whey paint. He began to rate about it. It's fantastic. I want to use whey paint and all. And then I pointed out whey was a wonderful paint, certainly very ecological, certainly very healthy and all. But where do you want to use this whey paint? Well, I want to paint the trim. No, that's not a very good idea. Adequacy of fit. You should unblur your children, by the way. It's nice to see the family in the background, Lucas.
I
But,
warned you to sneak through at least once.
Yeah.
Well,
But you know, the adequacy of the material to its purpose. So maybe you don't want to use whey paint on your trim because it's not going to last, because it's going to, you know, it won't provide any durability. It's not going to protect the wood. It's a wonderful product, but it's not going to be the right product for that application. So for me, the application is important, and that goes down to building science. You know, in what climate are you? Are you in Florida and you want to put like wallpaper on the interior of the house? You're going to have some real problems with the humidity trap between the wall and the wallpaper on the interior. What kind of cladding do you want to put on the exterior, and how will that work? You know, with the way that wall is supposed to move moisture during the course of the year. So the adequacy is important to me. And a lot of times there are concepts like, this is a very green product, let's use it. Well, maybe so, but maybe not. Maybe we're better off with latex paint on the trim than whey paint, because it makes more sense. And, you know, the environmental impact is important too, but it's difficult for consumers because so many things intuitively are wrong about environmental impact, and the fact that an item is environmental in one location doesn't mean it is in another. I'll take an example. Here in Ecuador, there's a lot of bamboo. It grows wild. I've been to bamboo forests. There's bamboo bridges and buildings and hotels. It's a fantastic material. But after that bamboo, much of which comes out of Ecuador, is shipped to Los Angeles and then trucked across the country to your house in Connecticut. Is it still an environmental product? It may not be quite as environmental. Maybe you're better off using something else, maybe something local. So it's difficult to see what the real impact is of a product. And we can talk about life cycle analysis software, and there's a lot of it, and I'll give you some to link to, but it's all quite complex. And I just think that nowadays, the main thing you need is some expertise. If you're a homeowner and you're wanting to do this, you really do need some expertise, like you do with engineering or with architecture. You can no longer just kind of do it because you heard something on a podcast, or you saw a show on HGTV and it seems like a good idea.
So yeah, pointing to the expertise, I mean, I think that's sort of getting to the root of like how can we answer this question for all the people. I want to hold that thought for just a second, because there's a few people in the comments that are very excited to learn more about the mid-level humidity information that Stephanie was talking about earlier. And I wonder if we can briefly just sort of mention where people can learn more about that, or how that's being applied to any practical work. Stephanie, do you have any comments on that?
Sure. First, you could feel free to, I don't know, do you have are you going to send around our emails? Because I have a vast bibliography on the value of relative humidity of mid-range, 40 to 60% relative humidity. But the other thing I just want to do, well, are there specific questions about that? Because I don't want to.
I didn't see a specific question, but just I think people are curious to know about that, you know, the benefits of it and how that's being studied.
So you can.
When does your book come out, Stephanie? They want to know when your book is going to come out.
Well, so
where can they find your article? That kind of thing.
I petitioned the World Health Organization in the beginning of the pandemic, and I said, this is a protective strategy that we cannot overlook. And so if you go to www.42to60.com, you'll see a lot of references. That was the petition site. But it's interesting because ASHRAE has been reluctant to endorse a minimum relative humidity because they're worried about reaching the dew point in a wall if the insulation doesn't prevent that. And so ASHRAE has been reluctant to say 40 to 60 is beneficial. And they released the infectious disease position document on November 13th, and they completely pretty much omitted it. And there was an uproar, not just from me. So now we have a expedited indoor air quality standard for infectious aerosol mitigation, and it's going to include humidification. So that's ASHRAE. You know, ASHRAE doesn't usually pivot so quickly.
No, they don't.
It's pretty remarkable. If you go on, if you connect to my LinkedIn, you'll see some pretty fiery posts that I wrote recently.
Fun.
Kind of like that kicking the hornet's nest thing.
Thanks.
But the other thing I
Would
wanted
you
to say,
Stephanie,
What?
would you say, as a simple kind of rule, that we talk about natural things, that the human being is best suited for the natural environment? That's the environment in which we evolved, and that's the environment in which we probably should ideally live. That the closer you come to a more natural setting, as a general rule, the healthier it is. In other words, we were talking offline about opening windows, and a lot of ASHRAE and a lot of the vent it right and build it tight and all of that ends up being with a very kind of restricted situation where the big problem is the homeowner opening the window and throwing the whole system off. I've heard that many times at the ASHRAE conferences and such, educating the homeowner not to open the window, not to touch the thermostat. In other words, not to modify the environment to their comfort. I find that antithetical to human life in a sense. And I wondered if there was some general things in response to people's questions about, relative humidity. Now we're going to be having special machines to control the humidity to a perfect level. Or is there like kind of what do you do at your home? Do you have a computer controlling the humidity?
So the couple of things. Do human beings do better in a more natural environment? I think so. For example, but if you look at outdoor relative humidity, not absolute, it's frequently in that good zone, even if you live in northern Vermont like I do. If I were to be outdoors, it'd be freezing cold. There wouldn't be a lot of moisture in the air, but the relative humidity would be in a fairly good range. So it's not sucking water out of my cells. We don't really want to live in 0 degrees in the wintertime. But I think Mother Nature actually, this will sound really, granola-y. I think she gave us that 40 to 60% range to be healthy. And yet, as brilliant human beings, we build these structures with synthetic materials, withstand compression and tension. We seal them up. We're super comfortable. And in the wintertime, in the heating season, in temperate climates, we warm up the air, the relative humidity plummets. And what happens, I think, is that pathogens, viruses, bacteria that can survive in those conditions tend to be the pathogenic ones. They're like, this is awesome. We have free airfare. We can infect people ad infinitum. And the human being in that setting has their immune system compromised. Autoimmune disorders increase, inflammatory-based diseases, even, GI disorders, obesity, type 1 diabetes is related to inflammation. And I know I sound like I drank like the humidity Kool-Aid, but I think that low relative humidity is so harmful to our health. It's just incredible. So that's a long-winded pre and post-amble.
I mean, incredibly fascinating though, and syncs so well with stuff I experience, I'm someone who's quite chemically sensitive and also has Crohn's disease, for full transparency. So, and I deal with living in a house where average humidity is about 27%, maybe, because it's Tucson, right? And it's an older house, and we're in the process of slowly upgrading it to be a good home, but we have a ways to go in terms of many air quality metrics, but relative humidity in particular, and to learn how important that is to the other metrics as well.
Yeah, it's really, and because, if you think about the chemistry, if you think about gas surface partitioning of VOCs, of, NO2, SO2, the factors that influence whether something's going to be in the gas form or on a surface is really energy. So it's going to be either latent heat, which is humidity, or sensible heat, which is temperature, which you obviously can feel. But when you manage the humidity, you actually reduce the number of many toxic chemicals that are in the air because you put them back out of the gas phase. So it's protective beyond what I, in a million years, would ever have predicted.
So I think we've established that our location is so important, but even just how we actually manage our whole environment make a difference in what materials we choose for that indoor space. Yeah. So, hey, Lindsay, I'd like to hear from you again. I mean, being someone who is making these sorts of decisions, one, could you kind of talk about your evolution of have you always have these types of decisions always been on your radar, and how have you learned about this stuff over time? Thinking about a practical evolution. Like I heard about life cycle analysis when we were first starting Green Building Advisor, but I don't think most people knew what that meant or even how you could go about doing it. And like, so how have you sort of made the solid choices that you feel confident about the materials that you put into the projects you work on?
Oh, that's a great question. I think we started out initially just wanting to do less bad, right, in our assemblies, and just trying to train ourselves and educate ourselves about what we needed to know about what was conventional in the construction market and where there were spaces to improve. Like, we already knew that natural materials could be better, but like, if they're not in a conventional market, it's really hard to talk a contractor or an owner into using those materials. And so it was a slow moving process. And even internally, we internally in the studio have daily debates and, rundowns on like, well, okay, let's qualify this particular material, but then how does that material comply into the sandwich of the assembly? And how does that assembly comply with the sandwich of the assembly next to it? And ultimately then, in a site specific way, are we also still meeting the goals of the project? And so while we've tried to establish, like, we would love it if we could say, this is our go-to wall assembly, this is our go-to roof assembly. We actually aren't able to specify just one. We still have a range of those. And then within those, we find that we're still adjusting per project to fine tune everything. And this is one of the things that makes it really complex, not only for designers, but of course for owners and contractors and everybody that's trying to understand this. Because wouldn't it be great if we just had, a sort of a recipe per region? And we find that, the complexity of the site specificness, the particular sensitivity of the occupants, the intensity of the use of the occupants, even just like, is this a seasonal home or a year-round home? Is this for a bunch of commercial uses in our commercial work, or is it for a single family that has very particular desires and goals for their house? So as we went along, we first had to be kind of courageous and experimental, but ultimately we were relying on the building science that was behind what we were putting together. And we were looking at, energy modeling and therm modeling through the wall to understand moisture transfer. Because, to the point of this whole discussion of relative humidity, it's moisture management we find that becomes the really critical factor of keeping the indoor air quality high. And also, having a good contained thermal envelope that's going to help us with energy efficiency. So for us, that evolution started with, dipping our toe in and honestly using some materials that we wouldn't specify today. So like, for an example of that would be to estimate a project and realize that the one building a system that meets the owner's budget limitations is perhaps a foam-filled SIP, right? Well, in hindsight, or once we did that and we saw all of that material show up on our job site, it was sort of like, all right, guys, never again. We're not doing that. We're not doing this. And we're gonna push and try and find other assemblies. And so it gave us, I think, the courage to say, we're gonna go with a straw panel project, for example. We're gonna go with a cross-laminated timber if we could. We're gonna go with a cellulose-filled wood frame structure. And over time, I think we were able to prove those materials, mostly because in our market they were super new, but in other markets, like we've got a bunch of people here from New England, those things were not as new and the community was more comfortable with them. And so with leaning on some of our colleagues and some of their expertise, we could also say, hey, I think this is legitimate, and ultimately our contractors trusted us and the information and data that's behind those materials and systems, and we're able to get it built and then now have a great outcome in the resulting structure. So it's like it's a frustrating, slow process. So if you're at the beginning of trying to learn about this, remaining patient and being willing to accept some successes along with some, struggles and failures, I think is to be expected.
Now, I'm going to stick to the word that you just used there, process, because the one thing that I'm thinking after listening to you talk right now is that you mentioned, early on getting into research and then having these constructive conversations on a regular basis. And, is that a formal process that you involve in your work, or is it just that you were fortunate that you all have that same passion and curiosity? And is it a consistent process that you've developed as part of your workflow?
I think we're getting there in terms of formalizing the process and routinizing the routine. But I think we also realized, early on that these are the kinds of projects we want to participate in. And so there are, and it depends on if we're empowered, and if we are, like in our commercial sector, we're more often seen as, to a certain level, the experts when it comes to those things, and they want our expertise. And then there's some limitations in the single family market, right? I mean, at the end of the day, this is a person's private home, and they are the expert on their private home. So we can provide information and have robust conversations around it. And we also learned really early that we can't just talk to the owner and get the owner's buy-in. We have to be sitting on the same side of the table as our builder. And our builder has to be a partner in all that. And they have to help us make those decisions, because they're ultimately going to be procuring material, bringing it to the job site, making it happen, understanding the sequencing that's critical to air sealing, and like not just having the owner hear it out of our mouths, but to hear it from the builder. So in terms of process, we realized that we needed to bring those builders in and bring them to the table as soon as we could. And that really so we operate in terms of process sometimes more like a design build, even though we stay on the design part of the process professionally.
Lindsay, you speak to something I think that's so worth highlighting. Is I think for so many of us in the green building world, when we started doing green building, you show up and there's dumpsters full of OSB and foam insulation, and you're like, what is this?
Yeah.
Like, I feel ripped off. Like, what is going on here? There's something wrong here. Oh, but it's efficient. Don't worry about it. It's going to be fine, right?
Yeah.
And then you begin to dig deeper and deeper and deeper. And maybe you can speak a bit to this too, because I found one of the most interesting things about using what we call good materials, being like healthy, durable, low carbon, high quality materials, is that for the builders who use them, they're more excited about them in the end. They may present challenges, but they're not going home at the end of the day with headaches from toxic exposure. The, say, wood fiber insulation cuts with standard carpentry tools a lot better than foam.
I love it.
That kind of stuff, right? So it's once you build that, I like to call it a high performance ecosystem in your market, it does kind of build upon itself, right? We're trying to do that in Phoenix and Tucson. Phoenix in particular is very challenging. Tucson has a long history of good building. But we found by putting, say, wood fiber and actual plywood and stuff on our buildings that we're building down there, GCs will be driving by, you see them double take, they pull over and they're like, what is this stuff? It does have this magical ability to build excitement. Another thing to tie back to is procurement, and maybe we can address that too a bit, because like we get people very excited about these things, and then too often the answer is like, well, good luck getting it.
Yeah.
Right. Or like we're saying, the project hinges on the window package, and then the window package is, forever away into the future. And I think that, when we talk about materials, we also have to be willing for the, the balance of all the factors to weigh out. And if we have to be careful that we don't get too stuck up on our ideal outcome, because we might push too hard and not resolve at the good compromise that works for everybody. And we try to win as many of those conversations as we can, but we also expect that we're not always the one making the decision. And I'm wondering, with Lacey, we're specifying, perhaps that there's another sort of lever you have there, and to make sure that your contractor understands the performance goals of everything that they got to show up with. But we also have to accept, making good arguments about things and giving good information, and then ultimately trying to figure out how do we actually get to the outcome where we have a building instead of just a bunch of drawings and a big conversation around it.
It's a great point. Lacey, I wonder in your work, you're working on specifying things. I also do a lot of specifications. Then let's say you can't get it. People will be like, let's stay with insulation because it's a subject I'm most familiar with. And they're like, oh, well, I got this thing. It's like actually higher R value. It's going to be great, right? And not understanding that they went from something very carefully specified to something that's fundamentally different other than maybe one criteria. And do you have strategies to get people to stick with the specifications you do, or understand why they were specified?
Yeah. And it's really simple. It's just collaborating and talking to people. So one of my, strengths or priorities with my company just in general is to build relationships. And so when you start a project, whether it's someone that you've worked with before or not, like just building that relationship, that open communication, so that you set this sort of level of trust. So it's not this me versus them sort of scenario of like, I'm going to be this sort of, sustainability dictator. But it's more of a partnership and a collaboration and an understanding of, okay, yeah, like this is my ultimate goal of what I want. If you can't get that, then let's talk through some different options. What can you get? And let's try to work together to find that solution. Because you guys are right. Like, you're not always going to be able to get exactly what you specify, whether it's lead time or just availability of product in general.
And
It's hard. Yeah.
I'll add one quick thing. One of the things we say, although this terrifies some GCs unless you know them well, and this is why you speak to something critical, which is building relationships where people trust you. You know how in product specifications, there's the easy to get products and there's the specialty products, right? We like to say everything's a specialty product. We put that much intention behind specifying that product for that purpose, and they all work together as a system, that you can't just substitute one thing like the sheathing type
Right.
for nothing. Right? Everything is a specialty product, and they need to be approached as such. Like, you might be ordering your installation 16 weeks ahead of time, like a high-end custom window. But guess what? It's worth it when it's not piles of foam that you have to cut up and choke on your site.
Mm-hmm.
Not to get too fired up. You can.
A lot of it is specifying your subs. The sub specification is another criteria.
Oh, yeah.
Identifying people who are in the spirit of it. What you're trying to do, which is beyond just building something and sending out an invoice, and that can be takes time, and it has to be done locally. I've built in many different places and had then the challenge of finding the right people in the different locations, and sometimes the impossibility of doing it. So it's when I saw my electrician driving an electric van, I knew that was my electrician. I said, that guy's going to understand. But then, others don't, and you have to be on site, like really kind of educating them. And a lot of people do like to learn, because it takes it from being kind of a drudgery, kind of a low, a menial manual labor job into something more meaningful.
100%.
Something a little bit more significant. When they get involved in the story of why they're doing it and how it's working, et cetera, it's more interesting. And so it kind of revives their interest a lot of times in a trade that they're not particularly in love with, that they're doing because they need to make a living. And now we're doing it because we're trying to achieve an objective. As a magazine writer, though, it also helps to bring a camera along and let them know that that have something to send to their mother at the end of the job. They buy into it a little bit more. But finding the right people is as difficult as finding sometimes sourcing the right materials.
So now,
can I mention one thing here?
go ahead. Yeah.
And it sort of taps into what I'm going to get everybody's names mixed up.
You're not going to say that sub-attitude is
No, well, like
basically
Fernando, you were saying like get people
triggered to the
engaged.
relative humidity.
Well, no, I wasn't going to talk about that per se, and then Lindsay, you said this early on, like don't tell people that they're wrong and you're right, because that will
Yes.
go nowhere.
Yeah.
But one of the things I'm doing now is actually monitoring spaces for things you can't sense. You can sense heat, you can maybe smell VOCs when they get to a certain range. But so we monitor these things. We have a health score. And so I'm in this office in a building in Stowe, Vermont, and I put this monitor in. I got my health score, and it was like 4:00 in the afternoon. It was terrible. And I thought, oh my God, 4:00 in the afternoon. I'm tired. I have a headache. I go home and I get mad at my husband, tell him I'm working too hard. He doesn't have a headache, so he's not working hard enough. But so I thought, okay, well, maybe it's carbon dioxide too high. So I opened my windows and nothing good happened. Maybe my relative humidity, that was a little off. So I humidified, didn't help. It ended up that during certain times of the day, sunlight was coming in. It was hitting a wooden table, and this is a fairly small office. And the cleaning material was actually an unsaturated carbon double bond between two carbon molecules. So the sunlight was coming in, and the photocatalytic process was actually releasing VOCs that were combining with the ozone from my printer and creating particles. and so in this monitoring journey that I've been doing now, we put monitors in people's offices or homes or wherever, and people are able to say, oh my gosh, in a senior living community, people shouldn't recharge their electric scooters next to the craft room because you're having these interactions that are resulting in particles that are exacerbating. So this is a long-winded way of saying, by getting people engaged in the intellectual process of what's going on in an active, it's really fascinating. I think people tend to want to be involved.
The work that you're doing is, in my mind, the most critical missing piece of our industry at the moment, beyond just, indoor air quality, let's say whole building monitoring, right? Rob, the first question you'd asked is how we make our decisions, right? And tying this back into that question, kind of the theme of today's panel is, we make these decisions based on laboratory testing, past experience, et cetera, without acknowledging the truth that every building is an experiment to one degree or another, because we don't want our clients to know that, because that's not a good sales pitch. We do tell our clients, though, that every building is an experiment, and we're acknowledging that, and we need to collect data on buildings, because that's what science is. You put forth a hypothesis, the building's the hypothesis. Let's collect some data on it, right? And that, to me, is the biggest missing piece, is active real-world data collection in buildings to really suss out things that we think are true and prove them with data.
Yeah, and correlate them with human health data if you can get it. And if you're really lucky, you can get the third dimension, which is the microbiome of the air and the surfaces in the building, because we live in a very holistic world by definition.
Well, and it's interesting, that same data you talk about all the time, like you've been talking about with the relative humidity. Yes, we're looking at that from an indoor air quality standpoint to some degree, but mostly we're tracking that as a proxy for moisture failure risk in our structural assembly.
Exactly.
Right? So it's like
we're worried about the building and the performance of the building. Will the wall rot? And we're actually creating human habitat, but there's no human in our calculation. The human is completely absent from it, right?
Yeah,
you're so right.
We'll just see that data from that perspective instead of this more holistic perspective of it's fascinating. And just
although
we need to
if we were the Mona Lisa or a book or a piano, you can believe we treat we treat artifacts better than we treat our kids.
Yeah. So now there's all this hype during the worst period of COVID about all these sensors and air cleaners and things that people were putting in their houses, and I feel like so there's a lot more awareness of even that as a thing now. Do we feel like, is the technology there? Because I know a lot of the really serious building science geeks that are builders or architects or engineers are just they don't build a house without putting moisture sensors in the wall to see how the condensation is on the insulation is going and all that. But are we at a point where, just like Lindsay, you were talking about how we want to work for people who are already interested in doing this stuff. So one, are people educated enough about this now? And are the tools there? Like someone asked, what instrumentation is recommended for monitoring in offices and homes? Are there plug and play options for this?
So I use a building. We had a building for health monitor built, and then it ties into a platform, so you can get a health score, like not just like what's there, but how is it impacting your health, and then you can drill down to the individual metrics. And we also automate remediation recommendations, like we also monitor the outdoor environment. So it tells you what to do in the most energy efficient and cost effective way, so that you're not chasing your tail by only tracking, say, CO2 or particles. So if you go to the B4H Inc.com, you'll see.
Could you say that again?
So just think building for health. Building is a noun and a verb. So the letter B, the number H. No, wait, sorry. The letter B, the number 4, the letter H, and then INC, like Inc.com. But that,
And this is commercially available? You sell this device? Yeah.
Yeah. And the thing is, I believe you need to monitor holistically so you don't end up getting into a chasing your tail scenario where you're only following a couple metrics and there are unintentional consequences. But the other thing, Rob, air cleaners are not the same as sensors. So I just want to,
Sure.
you kind of put them together in one
Well,
sentence.
I was just using it just as an example of the fact that, as our builders, as our homeowners, as the people who are supplying the materials, our subs, as they become more aware of these things, I feel like it's giving us more opportunities to incorporate them in our work and not feel like we're trying to force things on people. And,
One thing that I think that happened, it's just interesting timing in hindsight, was people paying attention to indoor air quality, both because of COVID, but here in the Mountain West because of fire season.
Yeah.
And having a pretty serious smoke event, all of a sudden, we got phone calls at the office. People were like, "Hey, Lindsay, what do I do in my house if I, can't shut my windows at night?" And there's not like a product that I can send them a link to on Amazon that's going to do that for them, right? So we have to really think about a complex solution to that. But it emphasizes that if we're going to build a new building, if we are so fortunate that is what we get to do, we really need to value things like healthy indoor air. And it's just something that people didn't pay attention to earlier in my career. And now they come to us sort of already assuming that is, knowing we're going to provide that, but I don't have to educate around that. And I think that, one of the challenges also about, the whole open windows thing, we often, don't even have air conditioning in the Mountain West if we have good, robust assemblies and proper orientation and overhangs. But how do you what do you manage if you're not night flushing, right? If it's a smoke event outside, you're not going to open your windows at night. So thinking through the balanced ventilation and realizing that mechanical balanced ventilation and having that as an option for the house and having it to be trusted in there was a huge resource in the event of not just sensitivity to allergies in the spring, like I get, but also, a really serious smoke event that we're starting to see year over year. We have to expect it now. And it's a bummer, but it has really increased people's awareness of their air quality in their home.
It's so
Do you do
interesting how
anything?
people talk about mechanical ventilation and windows as these oppositional things, right? When they're really fundamentally both trying to achieve the same utility of good indoor air quality, right? And comfort and joy in the building, right? So I think, Lindsay, you said this well, you need to be able to design for all seasons, right? There's times of the year down here in Tucson, like during the day this time of year, doors and windows open, fantastic. But in the last hour, it's dropped something like 20, 25 degrees, and I would be freezing with windows and doors open right now. So time for the mechanical ventilation system to do its work, right?
Yeah.
These things need to work together, right, to achieve the utility. And ideally, let's collect some data on them along the way.
So I have a question for you people who design homes and specify products. Do you ever see different uses of spaces based on occupant vulnerability or for example, in a hospital, I think the more vulnerable patients should be put near the core of the hospital, put holograms of trees and stuff, let the people go home and see nature. But in a home, do you ever specify vernacular architecture or architecture that has different uses? Like a sleeping porch in the summertime might be different from a core room in the wintertime in a cold climate like Montana, Lindsay.
Well, we definitely, I don't think we've done it from, say, a ventilation standpoint. That always wants to be balanced throughout the house, but we definitely have done it from a lighting and acoustic standpoint. And it's interesting how often now we'll talk about, do you need an acoustically private room to Zoom from in your new home, right? That was a question that we never asked a few years ago. Right. And proper humidity just for throughout the whole house, throughout the year. We go through both, humidity is relatively low out here and it is dry. And so we're adding in air, and we're finding that if we don't have the proper mechanical systems at our projects, because of the air tightness, they get too dry. Right. Yeah. And they lead to other issues. So I think that we've never gotten in, say, a residential project, any variability throughout the project where we've gotten to specific rooms. I think, maybe one anecdote I could tell is just, one client wanting a cigar space. And that was a very sort of special or a wine room. But generally speaking, we're specializing more to do with daylighting and perhaps acoustics.
Because if you think about the human body, which I love like to think about how Mother Nature does stuff, your more vulnerable tissues are in a different part of your body than the less vulnerable or more adaptive ones. So why don't we do that in our buildings? Why don't we have like a variable vulnerability score, sort of? I just thought of that.
The core of a lot of our design work, or really the core of our design work, I can say it that strongly, is biophilic design. Following principles of, really our focus is on creating buildings that maximize human joy, right? And we're also trying to solve the climate crisis through these buildings, but that's the part we tend to talk about a lot less. Like one of the things we focus on is, like, we say step inside for fresh air. Super cheesy, but it's a powerful statement, right? And one of the things
I'm gonna steal that.
One of the things we've done at our current project called Valley Muse, it's inspired by London-based Muse designs, where it's these micro neighborhoods, right? It's 4 units, they're all close to each other. They have a shared party wall that's 1 story. And we've created these slot canyons, which is a thing that you really want in Arizona, because it's where shade and water and relaxation is found, right? But during middle of winter, that might not be the ideal space. So there's also a courtyard that's going to get a decent amount of sun in the back. There's a 2nd floor patio that's great for shoulder seasons. And then we have this private kind of bottom of the canyon yard that's also your entry experience. That's perfect during summer, right? So designing these outdoor spaces that you can be in and connect to in all seasons was a huge challenge, but definitely well worth the effort, I think.
Wow.
People used to actually move to different houses during the different seasons. The Navajo Hogan had the summer Hogan and the winter Hogan, and that was a fairly common to have semi-nomadic life, not moving all the time, but moving for the season to the right environment for that particular time of year. That makes a lot of sense. I wonder, all of you, been talking a lot about carbon and mitigation and this and that. How many of you have really given a lot of thought to adaptation, in the sense that, like, COP27, the big environmental conference that just happened in Egypt, the focus has moved away from mitigation as kind of a lost cause. And now, how do we adapt to climate change? Lindsay was talking about a very real thing, there's suddenly, we can't open all the windows because there's smoke outside. This is a direct effect of climate change. And how do we adapt to climate change? And the question, that always comes up, at least in my experience, has to do with relying on mechanical systems, where I understand totally what you just said, Lindsay, was very clear. I agree with it. And it seems like a real quandary. What do you do? You can't open the window all the time. But at the same time, what do we do when the networks fail and such? And how are the houses going to be able to adapt to a future sort of crisis? Do you give any thought to it?
Oh, well, I mean, I think we're still sometimes operating, we're usually connected to the grid, but a lot of our projects are actually completely off the grid. And so there does include sometimes some generation of power through PV. Oftentimes where we're still operating on a backup generator that is going to use some fossil fuels, which it's the same with other insulation products, where we say we don't recommend this or we don't recommend that. And that comes down to the compromise of what is the right set of decisions for a project. But I think that the wood smoke thing is relatively new, in that it's just more in the front of mind of our clients, where they are scoring higher the desire to not be bothered by the wood smoke because they have good air sealing in their house and their mechanical system is properly balanced, where they have constant thermal comfort inside, regardless of what's going on outside. But yet it's not such a complex mechanical system that on a typical day, they don't just, if they want to open their windows, just open your windows, right? It's not so high tech. It's really based in very, old principles of passive cooling and heating, but yet we're balancing it in a way where it gives us a consistency of expected thermal comfort throughout the year. And I think the challenge of modern buildings, of course, when we go completely off grid, is just, at a whole other level. Thinking about, how long are we trying to maintain a certain level of thermal comfort? Is it an hour? Is it a day? Is it a month? And that leads to the parameters that we have to respond to in order to provide that. So it gets super complex very fast.
Yeah.
You say that so well, and it's such an interesting intersection between what works well for resiliency and
Mhm.
what works for maximizing comfort, health, and minimizing carbon impact now, those things tend to be very similar, right? In our work, we tend to focus on incorporating, solar with batteries, and then, water with capture. We're even trying to integrate some degree of urban homesteading with being able to grow your own food on your site. That kind of stuff is so important because we really don't know what the future is going to hold.
Yeah.
And we're trying to kind of approach our design as from the beginning as if, okay, if this were to be off-grid, even though this is, say, in the middle of central Phoenix, urban infill, if this were to be an off-grid project, what would it need to have moving into the future? And how much of that can we incorporate into the buildings now, so that, let's say, just electricity gets out of control expensive. Now you're producing and storing your own power on site. You might not need it to survive, but you might need that to thrive. And, I think our goal should be thriving, not just survival, right?
Well, we're watching every night the tragedy in Ukraine, and it makes me wonder, if I was under similar circumstances, facing a whole season without power, etc., in this house I'm in, would I survive? What would I do? Where would I cook? How would I, it makes you question those things. And that's what I'm talking about, adaptation. We can see that if it'll happen, when exactly it'll happen, we may not know, but if our homes are adequate to it, if you could actually like an old country house, you could probably survive it because you can make a fire in the fireplace, you can do all that. In the 57th floor of a skyscraper, you're done, right? Like they talk about how in New York City, the carbon footprint of an individual is very low compared to what it is, in Wyoming or Montana, because of the urban area. However, you're going to survive much more easily in a place like Cheyenne than you will in a skyscraper in New York. So there's a value to think about now beyond carbon, in terms of is this going to be a shelter that can last through the coming decades with whatever it's going to throw at us. Because watching Ukraine really brings it home to me, because it's so evident that we see it every day on the TV. So it worries me, because I know my house in particular. No, I won't do well. I mean, I'll suffer a lot. And fortunately, as Rob pointed out, I'm towards the latter part of my life, so I won't suffer all that long. but still,
I'm never going to live that down, am I?
Are you talking about Ecuador or Houston?
I'm a little bit north of Houston.
Oh, but you're not. I didn't know if you're talking about your home in Ecuador.
No. My home in Houston. Yeah, I hoped during the climate calamity I'm in my home in Ecuador will be much I can fish in the backyard.
So I just want to mention now we're coming pretty close to being an hour and a half here, and I don't know how long everybody was planning on sticking around. And I think we've established that it's really hard to break apart. Are you hearing
that's redundancy for you? That's redundancy for you.
We started echoing.
How about now? Am I better?
We started echoing.
How about now? Am I better? No, I don't know what happened.
And it's all of us too.
Okay, well, I think we've established that it's really hard to break apart these conversations from the bigger questions about building in general, about trying to choose materials. And so can everybody just sort of offer some closing thoughts on how people can approach this difficult task?
I have one quick thing, which is check your carbon numbers. That's one of the things, your embodied carbon numbers, specifically when you're selecting materials. Time and time again, I've noticed a trend of the low embodied carbon or carbon storing materials tend to also be healthy, durable, et cetera, et cetera. So if there's one kind of proxy to use quickly, checking your carbon numbers. One thing I wanted to circle back to is the embodied carbon impact of bamboo plywood. I've always heard about that as a super sustainable alternative. I was shocked to see how high the numbers were for the embodied carbon of bamboo plywood. Yeah. So it was one of those moments where it's really counterintuitive. So
Exactly, exactly. You need to look like you've mentioned again at the data, because it is not intuitive at all.
Yeah. And know that your ingredients create your results, right? Like be very, very careful and intentional about what you select to build with.
My parting words would be bring visibility to the health impact of your environment. So whether it's a hygrometer for humidity or like our beef rates monitor, we can't sense everything that's important. So I believe that some kind of monitoring to create that visibility, so you actually, measure it so you can manage it, to use that cliche. I think that's really important.
Yeah, I think for me, I mentioned the Ecomedia's website as a quick, search tool for different materials. The other thing that I would also add, that I found for our personal home project, not so applicable for some of the commercial work, but there's a free carbon footprint calculator tool called the BEAM estimator, BEAM. Some of you probably know that, but it's through the Builders for Climate Action. And like I said, it's a free tool, but it lets you kind of play around with different assemblies and things like that, so that ultimately you can see what you're designing, what you're building, and what that impact would be, and what the change would look like if you just swapped out different pieces of materials. So that would be the one other tool that I would recommend checking out.
Yeah, James in the comments was asking about what tools, and yeah, Beam is my go-to for sure. Yeah. EC3 has a great database that's available with a lot of EPDs.
Yep.
It's a little overwhelming.
Yes, exactly.
Yeah, the article I'm coming out with, this next one for the part of this series, I converted a lot of embodied carbon data around insulation from a previous Green Building Advisor article to pounds per cubic foot, which I find to be a much more useful metric for discussing these things than kilograms per meter squared, because I don't know if you guys
because what the heck is that?
Yeah, and a cubic foot is roughly the size of a basketball, in pounds we all understand. So it's a lot easier for people to understand that. So Green Building Advisors had some great stuff over time. If you just Google embodied carbon Green Building Advisor, you're going to find a ton of useful information as well.
Before we go further, I just want, someone asked if this is going to be recorded, this video. We do record our webinars, and I don't know if it's a little bit different on GBA, but I know for sure on Find Home Building, we always post them on the same page that everyone registered on, and I think that's how it works on GBA too. And I want to remind everybody on the panel here to, if you could just send me an email, me and Kylie an email with all of these resources that you mentioned. We'll also put those on the website on Green Building Advisor. So basically everyone go back to where you registered for the presentation. Just go into Green Building Advisor and find the expert, what do we call them again? The expert exchange. If you search for expert exchange on there, you'll find the page for this, and we'll have all these resources available for people after we're done tonight. So let's see, who haven't we heard from?
Yeah, hopefully you guys can hear me. I think my internet might be failing me tonight, but
You're good.
I would advocate, for finding ways to make the design elements objective, whether it's to your clients, your contractors, whomever needs to be educated on the qualities of those products. And, we use something as, PHPP, the Passive House Planning Package for energy. We've looked at Design PH as a modeling tool. We've used a fairly robust software tool from Cove for a whole building analysis. And we found that BEAM tool to be particularly effective for individual materials. So advocate for all of those things, and I can send links to those. But I was just going to share that for our clients that don't necessarily want to get into the weeds so deep with us, but they want a consistent graphic, we've had success with really simple diagrams that characterize their building had it been specified to say code minimums, and then where we're specifying their building. And it's as simple as saying big red line on this table next to significantly smaller red line over here. And all these things are achievable within your budget. These are achievable within your schedule. And you just give them the open door to make the right decision. And we found that to be really effective, and finding ways that are digestible for our clients without overwhelming them with data, because, you know, their eyes will glaze over and they're not having fun anymore. And we want to make sure that everyone stays engaged in the process. So I think finding the right tools, that then finding the right audience for those tools as well, is part of the mix of getting the right materials executed in your project.
Great.
I also wanted to say for those of
I also wanted to say for those of how many people have
a dog?
how many people have a dog?
Because unless you're frankly allergic to dogs have a very healthy microbiome.
Very healthy
And I saw that somebody recommended that book, Never Home Alone by Robert Dunn, about the microbiome. One of the easiest ways to create a healthy microbiome in your home is to get a dog. Not cats.
Right.
Cats are a little different, but we can talk about cats.
So you specified dog in your plans now.
I actually have 7 dogs. The only problem is my husband doesn't like dogs. So we have different issues in my house.
So Lindsay, you will now specify the dog.
Yeah.
And well, why do I need a dog? It's funny. I just built a house that has a.
It's a rule out here. You have to get a dog.
I just built a house that has a type of flooring called dogwood flooring. It's actually like a hickory base, but it's this densified wood, an engineered wood that Bruce puts out. It's a brand new product for them. And I put it on my house as they gave it to me as an experiment. But I'm required to find a buyer with a dog. So that I have to ask the people that move in, do you have a dog? Because I have to sell to someone with a dog. Because apparently the floor won't scratch and stuff with the dog. It's a surface made for dogs.
Wow.
So,
What's it called?
it's called dogwood flooring. It's with Bruce, but it's not there is a dogwood, an actual wood called a dog. It's not made with dogwood, but it's called dogwood because it's a floor designed for the nails of dogs not to scratch. And it's a wood floor. It's a very handsome floor. I haven't dog tested it yet, but I'm looking for a buyer with a dog. Maybe you'd be a candidate.
I was going to say, I've got big dogs, little dogs.
Yeah. So my only thing is I've been working a lot with designing a community for adaptation, for future adaptation. So my thinking has all been about that. So I'm working on assemblies for new homes. It's easier than although there are things you can do in remodeling too, to just create a house that is more will be more resistant to whatever hazards are in your area, like floods and wind or fire or whatever it is, and how to create the shell that will minimize the damage, particularly with floods, which are really devastating to people. Even a couple of inches could destroy the house. So working with materials and such that are not so susceptible to to damage by humidity, and creating building assemblies that will work. So my guidance is a lot towards the new housing because I'm not involved in the remodeling.
Interesting.
Very much at all. Although you can do things too. There are sealants and stuff you can use to keep water out from a house, minimize the intrusion of water, and certainly things you can do to improve the wind efficiency. But even shapes like a hip roof will hold up to the wind much better than a gable end. Things like that, little design items that, hey, if you're going to be building and you're in the hurricane zone or you have tornadoes, you may not want to build a house of 7 gables. You may want to just build a simple hip roof. Do you want a 2-story really, or maybe you ought to stay closer to the ground? And things like that. Because all considerations aside, when you suffer a flood, when you suffer a fire, when you suffer really extensive hurricane damage, it is devastating to your life. And nowadays, the insurances do not cover the restoration completely. So that's been my focus, I guess, because of you always focused on what you're working on. For you, it's indoor humidity. For me, it's environmental.
Are you speaking from experience about that?
Yes. Oh yeah. I've worked a lot with FEMA and
No, but have you had any destruction?
Personal? No, I haven't had thank God I haven't had a personal experience with it, but I have seen so much of it, and I have been with families that I know were bankrupt or were truly devastated. And just the loss. I see all these pretty things behind you right now, the little elephants and things. All of that gone. All of your baby pictures gone. It's just. Yeah. when you're with the people, it's just like parents that suffer the loss of a child or something like that. You grieve. You cannot help but empathize and grieve with it. And so I realized how important it would be to provide a house that has some protection from those devastating events that apparently will be hitting us all, or certainly hitting us all with a lot more frequency. So,
Well,
if your kids inherit the house, will they be able to inhabit it in 20 years?
for sure. Well, I think that unfortunately is all the time that we've got today. I want to thank you all, Lacey, Stephanie, Lindsay, Fernando, and Lucas, for joining us. Unfortunately, Lindsay's internet might have finally given out on her there, but at least she was here for the full conversation. And again, I want to thank Rockwool for sponsoring today's presentation. If you visit their products and applications tab on rockwool.com, you can find everything you need to choose the best installation materials for your next project and install them correctly. And of course, I want to thank everyone in the audience for joining us and for having such great comments and questions to keep us on our toes and keep us sharing some practical information. So thank you everybody for coming, and I hope we see each other all again soon.
Thanks, Rob. Thanks, everybody.
Thank you.